have any questions over that radical equations worksheet, I'd like to start there, okay? So let's start there. So number one, well, actually, you're supposed to do 2, 4, 6, 7, and 8. So let's start with number 2. Number 2, the answer, and then you can tell me if you need me to go over it. Why are you not working there, pal? There you are. Okay, so the answer for number 2 was 45. K equals 45. But in reality, that was what we call extraneous, so it wasn't the answer at all. We'll deal with that one. You might need me to go over that one. Did you get it up here? Did you already pick it up? Okay. We had to do 2, 4, 6, 7, 8. 2, 4, 6, 7, 8. Does anybody need me to go over that one? Yes? Okay, let's go with this one. Okay, so if you weren't here, or if you've forgotten, what makes this a radical equation? What do you notice? You got a square root above 4k minus 11, and then on top of that, it's got an equal sign, right? So this is a radical equation. So the first thing that you have to do with a radical equation, you have to get this radical part isolated. What does isolated mean? Alone, separate. So to get that separate, there's one thing I need to move away from it. One thing that's not underneath that radical, and that's the what? The 15. So the 15 has to move, and how do we move it?
Subtract 15 from both sides.
All right, so when I subtract 15, that does isolate the square root of 4k minus 11. And on the other side, it leaves me with 2 minus 15, which is negative 13. Okay, so we've isolated our radical. That's the first step in solving a radical equation. The second thing is, you got to get that radical out of there. It's got to go. It's got to cancel out. Well, if you guys recall, y'all remember when we were dealing with this? What did we do to get rid of the square? We took the square root, right? Well, this is the exact same thing, but in the opposite direction. You see, now it's a square root. And how do we get rid of a square root? We square it. It's the exact opposite. So we've got to square both sides. But when I square the right side, I'm squaring negative 13. So that negative 13 technically needs to be in parentheses. You understand that?
Otherwise, they'll just give you a negative answer.
And that can't be our answer. Because negative 13 is on that side. It has to be squared. So that's negative 13 times negative 13, which is going to become positive. So here's the deal with the left side. It's like that radical and that square. It's like they erase each other. So what drops down on that left side? Exactly. It just drops down. And then, of course, on the right side, negative 13 squared is 169. And now we can just solve a problem for k. Okay? So how do I solve that problem for
Add 11 to both sides.
So what do I get when I add 11?
You get 4k equals 180.
Was it this class that I dropped this pen the other day?
Yeah.
All right, and now what?
You're gonna divide.
We're going to divide by 4, and that is how we came up with that 49 as the answer.
You mean 45?
Yeah, 45, sorry. 45.
Here it is. That's on my bad.
All right, so here's the deal. Because of the nature of radical equations, what we talked about on Thursday is it's one of those types of equations where even though you could have done everything right and the process of solving was done perfectly, the answer that you get at the end, it might not work. It might not really work to give you what you need it to give you. That is called extraneous. we went through our process perfectly here, and our answer is 45. But I want to show you guys something. If I go back up here and I plug in 45, what's 4 times 45? 180. 180 minus 11 is 169. What's the square root of 169? It's a perfect square. 13. What's 13 plus 15? 28. Does 28 equal 2? No. See, we did everything right. However, our answer is not right. It didn't work. So even though K really does equal 45, that doesn't work. It's called extraneous. That was the new thing that you've not really seen yet before. So that's kind of one of those unique things with radical equations. Sometimes the answer you get, it can't really be the answer. So it's extraneous. Yes?
Sorry, I was not.
No, you're fine.
How do you check to see if it's?
You plug the answer you got back into the original equation, and you make sure they're equal on both sides.
So it would be 4 times 45.
Yeah, 4 times 45, 180, like that. Minus 11, 169. Square root 169, 13. 13 plus 15, 28. 28 doesn't equal 2. It's extraneous. Okay, yeah, you just plug it back into the original. Okay? So that's number 2. Let's look at number 4. The answer for that one is 29. X should have equaled 29. Okay? Anybody have a question on that one? You want to go over it? Okay, here we go. 29. Okay, so if you look at this particular one, it's a radical equation, even though it doesn't have a radical on it. They call it a radical equation. And the reason they do that is because it's got a rational exponent. And we made the connection last week when I was here between radical equations and rational exponents. Okay, they're the same thing. X plus 7 to the 1/2, remember the denominator is the root. That's just like the square root of x plus 7. So even though it's written differently, it's still a radical equation. So my first thought is I got to isolate it. Okay, I got to get that x plus 7 to the 1/2 power alone. That's first. So what do we need to move to get that isolated? How do we move it? So what is negative 5 plus 11?
Positive 6.
So 6 equals the x plus 7 to the 1/2 power. Okay? Now it's isolated. We got to get rid of that rational exponent. Just like we had to get rid of that radical. So here's how rational exponents work. How do I get rid of them? I raise it to the reciprocal power. What does reciprocal mean?
It's opposite, so it'd go to
Instead of 1/2, it's 2 over 1, or 2, right? So the root is the denominator. That's the square root. How do we get rid of square root? We square it. Same thing. Okay? We're raising both sides to the second power. That's what we do. We raise both sides to the second power. Now on the left side, what is 6 squared?
36.
So 36 equals, and again, just like in that last problem where the square root and the square canceled, or maybe it was cube root, I can't remember, it was square root. The 1/2 and the 2 do what? They cancel. So what's the only thing that drops down? X plus 7. So x plus 7 equals 36. Now what? And you get 29. So x equals 29, and we're just going to check it real quick. Now, again, in your head, type it in your calculator. Do I have to type anything for this side?
No.
No, it's good. But right here, what is 29 plus 7? What's 36 to the 1/2? Remember, square root of 36. What's 6 minus 11?
Negative 5.
Does negative 5 equal negative 5? That's my answer. It's not extraneous. So I don't write anything. I don't have to write it's not extraneous. You just leave it. Your answer is x equals 29.
I'll just vote yes or check.
That's fine.
You should work it out and figure it out if it equals the same and equals in the beginning.
Then that's your answer.
And if it's not, it's extraneous.
It's extraneous.
Is there any like not under, but any other word? Like,
No, I mean, I would encourage you just to do that work with your calculator. So you can just literally type it in, and if the answers are equal on both sides, it's good. If it's not, you just mark it out, put extraneous. That's it. That's all there is to it, okay? All right, number 6. X equaled 18. X equaled 18. Any questions with that one? Pretty easy. And 18 did work, was not extraneous.
how do you do the negative 2?
All right, first, remember, our first goal is to isolate, correct?
Oh yeah.
So we want to isolate the square root of 3x plus 10. So what do I have to move away from it first?
17.
How do you move this positive 17 first?
No, you subtract.
Okay, I'm going to subtract 17. What's 1 minus 17?
Negative.
So negative 2 times that square root of 3x plus 10 will equal negative 16. Now, when negative 2 is out in front of that radical, what's it mean it's doing? So I divide. What's negative 16 divided by negative 2?
Negative 8. Oh, 8.
Yeah, positive 8, right? Positive 8. Because the negatives cancel, positive 8. So, did we isolate that square root? So we get rid of it by squaring both sides, right? So what comes down on this left side? Just the 3x plus 10, correct? And what's 8 squared? 64. Jonas, you've gone a little hard at that paper.
My eraser broke.
Next, we're going to do what to get x alone?
Subtract 10.
Subtract 10, so that's 54. And then?
Divide by 3.
And that's the 18. So x equals 18. Again, use your calculator if you like. I go like this. 3 times 18 is 54. 54 plus 10 is 64. The square root of 64 is 8. 8 times 2 is 16. 17 minus 16 is 1. Does 1 equal 1? Absolutely. Not extraneous. Okay? Again, type in your calculator. You'll do the same thing that we just did with our head. Okay? All right, number 7 and 8 look harder, but they're actually easiest problems on here because they both have radicals on both sides. So when you get rid of that radical, it just becomes a very simple problem to solve. And this one right here, what did we have to do to get rid of that radical? Square it, right? We get rid of square roots by squaring. So 3k minus 29 equals 41 minus 2k. So once you get it to this point, it's pretty simple. Because remember, I like to move the smaller variable. Which one's smaller, 3k or negative 2k? How do I move that? What's 3k plus 2k? So 5k minus 29 equals 41. What's next?
49.
What's 41 plus 29? 17 or 70.
70 is one of
And then you divide by 5. What's 70 divided by 5?
14.
So x equals 14. Okay, I'm going to just quickly go plug it in. 3 times 14 is 42. 42 minus 29 is 13. So we have the square root of 13, which is about 3 point something. Okay, 3 point something. Over here, 2 times 14 is 28. 41 minus 28 is 13. So once again, square root of 13, square root of 13, both the same. It's not extraneous. Okay?
Go back to number 6 so I can learn that one.
Got it?
I'm gonna have to want to get a photo of it. Cause it's gonna take long for me to have to reroute it, like, 'cause I completely done it entirely wrong. You're not in the shot.
That was for the picture.
Huh?
Give him the Ricky Bobby, what is it? He does the number one thumbs up.
I wasn't in it. I was like this.
He should have been in it.
I don't remember the picture. Alright, so
You wouldn't know.
the last thing, this last problem, might as well just do them all, right? This last one, it's the same thing. It's just a rational exponent. So you gotta remember, rational exponents are radicals, okay? You get rid of the radicals the same way you get rid of the rational exponents. Technically, those are cube roots of, right? Because the denominator is my root, right? Cube roots. How do I get rid of cube roots? Well, it's the reciprocal of 1/3, which is cube. So we're going to cube both sides. We're going to cube them. When you cube them, it's not like this huge thing that you got to do. It's just the 1/3 in the cube will do what? They'll just erase each other right out. So we're left with 3x plus or minus 21 equals 19 minus x. They just erase each other completely. And now we can just solve a problem. Which one do I move? The 3x or the minus x? So how do I move that minus x? So 3x plus 1x is 4x. Minus 21 equals 19. So 19 plus 21? Nuh-uh. One more up. 110. No, I said it wrong. It's one more 10 up. 41. Or just 40. And then you're going to divide by 4. What's 40 divided by 4?
10.
Okay, so x equals 10. Let's just check it real quick. 3 times 10 is
30.
30 minus 21? 9. So you have 9 to the 1/3. Okay, what's 19 minus 10? 9 to the 1/3. Does 9 to the 1/3 equal 9 to the 1/3?
Yes.
Absolutely. If you typed in your calculator, that'd have been like 2 point something. Equals 2 point something. Absolutely equal, not extraneous. So the only problem that you have in homework that was extraneous was number 2. That's it. The rest of them were good to go. Alright? So that's how you do it. And we're doing the same thing today. I'm going to do 2 more examples. I'm going to give you 3 more homework problems. Here's the difference in what we're doing today. You go through all of the processes that we've learned in the past. You just got to bring back something from the past. So, do you want to mark your homework now? It's number 9, 11, and 13. 9, 11, 13 is what we're adding tonight. Just 3 problems. And then what are we doing tomorrow? Review for quiz. What are we doing Wednesday? Quiz. Thursday? Test directions.
For that same quiz that we're doing.
No, for the Unit 5 test. There is no way I will get that quiz graded from a Wednesday to Thursday. Sorry. No way. I'm just not that good. I'm not good enough to do that. I'm sorry. Too many things to do when I go home. I do not think about school.
You can find without you.
Alright, so let's go to your homework, or back to your note sheet, I'm sorry. And I'm going to do, like I said, 2 problems. 2 problems. Alright.
Nobody said.
Let's look at number 13 and 15. That's what we're going to look at today.
Isn't it? That's right.
Yeah, note sheet. Yep, that's it. That's it. Your 13 should look like this right here. Square root of 8x equals x. Alright, so let me show you all this. You good? You ready? You solid? $1 billion baby?
Yeah.
Okay. Now, here's the thing that is the same as what we did Thursday. Is that radical isolated? So what do we do to get rid of it? We square both sides, right? We got to square both sides. That's the same. That's exactly what we did on Thursday, and for those problems that we've done today, here's where it's different. When I square that left side, what drops down? The 8x does. Not really, because it's a to the first, x to the first. Since that's the only thing that's left over there, we just leave it 8x. But what's left on the right side? Okay, here's where it's different. You see, last week, with all those examples that we just looked at, and all the examples that y'all did on Thursday, we can now just go through the process of getting x alone. But I can't just go through the process of getting x alone, because I got an x, and I got an x squared. So we've got to incorporate something that we did in the past. And that is, we got to load up one side. Now remember, which one's bigger? 8x or x squared?
8x.
No, not really. X squared is. Why? Why did I say that one's bigger?
Because it's got a bigger, exponent.
Yeah, your exponent determines what your lead term would be. X squared is my lead term, because squared is bigger than just the one that's with this x. So since it's positive on the right side, I'm going to move the 8x to it. How? I'm going to subtract 8x. So nothing will be equal to x squared minus 8x. Now, does that ring a bell now?
Yeah.
Like, what do I got to do to actually solve it when I get it to that point? We set it equal to 0. Are there any like terms? Okay, so what you're saying is, since they both have at least x, we can factor out a greatest common factor. We're going to factor out x. Well, think about it. If I factor x out of x squared, what does that leave me with there? X. And when I factor x out of minus 8x, what leaves me? What am I left with there? Minus 8, right? Minus 8. So look at this. We factor out of x, a greatest common factor, and it leaves me with x minus 8. How did that help me? Well, but if I combine the x's, won't I just go right back to there? There is a way that we can now solve it. We called it solve by factoring. We would factor it, and then what would we do to solve? We would set our factors equal to 0. Well, what are my factors? One of them is x, right? So can't we set x equal to 0? And what was my other factor? X minus 8, right? Can I set it equal to 0? And if I do solve that one, I do what with 8? I add it, so it's going to be a positive 8. Was someone just responding, or did they have a question? Did I hear someone talk through the mic?
Yeah, it's me.
Were you just responding, or did you have a specific question?
I had to tell you something.
You have a question?
No, I got into a car wreck, so I won't be able to.
Who is that?
Jamie.
Jamie?
Oh, are you okay?
Yeah, I'm good.
Okay, good, good. All right, so here's the deal. This is why this is different. We had to factor it and solve by factoring, so we ended up having solutions. 2. And we still need to check them same way. Okay, look. What's the square root of 8 times 0? 8 times 0 is 0, right? What's square root of 0? 0. Plug that 0 right back into that x. Does 0 equal 0?
Yeah.
So that one worked. It's not extraneous. Try this one, 8. What's 8 times 8? What's the square root of 64? 8. Plug 8 into there. Does 8 equal 8?
Yeah.
So that one worked too. Neither are extraneous. They're both solutions. Sometimes, guys, neither of them will be extraneous. Sometimes one of them will be extraneous. I maybe have seen it where they're both extraneous. That one happens very rarely. They're either both not extraneous or usually just one of the two is extraneous. You rarely see it where they're both extraneous. But anyways, neither of these work. They're both great. Done. Okay? Let me show you one more that might be a step harder. Go straight down to number 15. Now, incorporating what we did on Thursday, is this radical isolated? Yeah. So we can get rid of it. How do we get rid of it? Right, because the root is squared, right? It's the square root of. So we square it. Here's why this one's harder. I know to square the left side, it's done. But what about the right side? It's m minus 5. You got to square the whole thing. So you got to put it in parentheses and square it. So that makes this problem a little harder because the left side is easy because it's just 6m minus 38. But the right side, remember, m minus 5 means m minus 5 times m minus 5. So if I'm going to break this whole thing down, I've actually got to go through the process of multiplying all that out. And that's why this is a little harder, okay? Now, leave the 6m minus 38 alone for a minute. Let's go multiply. What is m times m? M squared. M to the second. What's m times negative 5?
Or positive 20.
No, that's coming. M times negative 5. Negative 5m. Then we distribute the negative 5 to this m. What's negative 5 times m again? Another negative 5m.
Please excuse this interruption. We just wanted to let everyone know to clarify that all students should be in homeroom today for Rachel's challenge. And also, we will not have outside lunch as an option. Thank you.
Right in the middle of fourth period. Okay. And then, of course, last you have negative 5 times negative 5, Kira. That's the what? That's the positive 25. Okay, I'm going to go ahead and combine those. What is negative 5m minus 5m? No, it cancels if the signs were opposite. Since they're the same, they're going to combine and give me negative 10m. So I'm going to change that real quick. Negative 10m here. So, we're getting closer, but don't we need to bring all this stuff over here? How do we move that 6m over there? Okay, subtract 6m to what?
10.
All right, we'll get that in a minute. How do we move that negative 38?
Add it to 25.
We add it to that 25. All right, here we go. And then we're going to have this thing ready to go. These cancel. These cancel. So we're left with 0 equals. That had nothing to combine with, so it drops. What is negative 10m minus 6m?
Negative 16.
Negative 16m. And then what's positive 25 plus 38?
I believe it's positive 63.
Positive 63. Okay, so this one's a little harder than the last one because can I just pull out a greatest common factor? No, look, that has no number besides 1. I can't pull any number out. This doesn't have a what? Variable, so I can't pull a variable out. So there's no GCF. But it is a 1, 2, 3, it is a trinomial. How did we factor trinomials? We broke it into 2 binomials. Remember how this works, guys? What times what gives me m squared? M times m. What here times what here gives me 63. Well, what are some things that give me 63? 3 times 21.
9 and 7.
9 times 7. What's the big one? 1 times 63. Y'all think of any more things that multiply to get 63 besides those 3 groups? 7 and 9 we already got. We just had 9 and 7. Same thing.
4 and 4.
4 times 4 is 16. Not 63. That's it, right? That's all. Okay, so here's the deal. How do I know which of those it is? Well, it's got to multiply to get positives. That means they're either both positive or they're both negative. So I look in the middle, they're both what? They're both negative, but on top of that, that tells me they've got to combine to get 16. Which of those 3 will combine to get 16?
9 and 7.
It's got to be 9 and 7. In whatever order you want it to be because they're both m minus. Those have to be my factors, guys. Well, what do we do with those factors? So m minus 9 equals 0 and m minus 7 equals 0. What do we do to solve that first one? Add 9, right? 0 plus 9 is? 9. What do we do to solve the other one? So m equals what?
7.
So let's just go check it real quick, and we're done. Okay? Let's check it, and we're done. Check the 9 first. What's 6 times 9? 54. 54 minus 38? 16. What's the square root of 16? 4. Go over to the other side. What's 9 minus 5? 9 minus 5. Does 4 equal 4?
Yes.
That's the solution. Try 7. 6 times 7 is 42. 42 minus 38 is 4. Square root of 4 is 2. Go to the other side. What's 7 minus 5? 2. Does 2 equal 2? Both solutions. Okay, no, nothing extraneous. So, y'all got 3 problems I want y'all to try tonight. 9, 11, and 13 from that worksheet. We'll go over those tomorrow, and then we'll do a what? Quiz review.
Then a quiz.
Quiz on Wednesday. Test corrections on Thursday. Alright? Kelvin, what you snickering about?
I was
Thinking? What you thinking about? Math? You're smiling at something you're thinking about. It's math? Oh. Yo.
7 and an extraneous 1
No, because 6 times 7 is 42 minus 38 is 4. Square root of 4 is 2. And if you take 7 and plug it in here, 7 minus 5 is 2. So 2 is equal to 7. So they both work. It's recording right now. So Caitlin, this class and your question that you just asked, it'll be on the video. So I need to stop that now. But yes, this will be the video over the notes from this class.
What about from last week?
Yeah, I got all of those.